Okay. So first one is like already yesterday what we discussed, the last topic is IP addresses. So what is an IP address? Logical address. Logical address. So in your network, you have more number of devices, like 100 devices are there, but we can divide using this logical address. So how we can separate each network and we can make a communication between these networks. Okay. So using this logical address only. So every system must have an IP address to communicate in the network, and all communications by IP address only. IP addresses can be changeable. Either manually you can assign an IP address or automatically you will get an IP address automatically from your DHCP server. Okay. So in your home, we are having a Wi-Fi router. That Wi-Fi router is act like a DHCP server. Or dedicated DHCP servers also there, like a Windows server based DHCP server, Linux DHCP server. Okay. So that your Wi-Fi hotspot, your mobile phone hotspot also act like a DHCP server to whenever it is connecting any devices. Okay. IPv4 two versions, IPv4 and IPv6 two versions are there in IP address. IPv4 32-bit size and IPv6 is 128-bit size. IPv4 represented in decimal format, IPv6 is represented in hexadecimal format. The total IPv4s are 4.3 billion IP addresses. In IPv6, 3.4 into 10 to the power of 38 IP addresses we are getting. It's a very big IP address. Very big number of IP addresses. It's very big IP address as well as number of IP addresses also huge number of IP addresses, billions of IP addresses. Okay, so this is how IPv4 is look like. This is how IPv6 is look like. And this IPv4 is a 32-bit and it is divided into 4 parts. Each part is separated by dot. So 4 parts means each part is 8 bits, which is we called as each part as octet. The first part we call it as the first octet, second one we call it second octet, third one we call it third octet, fourth one we call it as a fourth octet. So each octet is 8 bits. It means 256 numbers we can able to put it. So 0 to 255 is the range of each octet size. Okay. And the very first IPv4 address is 0.0.0 and it is like a next one is 0.0.1 and the last one is 255.255.255. So these are the total range of IP addresses. This entire range of IP addresses we divide into 5 classes. The classes are class A, class B, class C, class D and class C. The class A range is 0 to 127. Okay, and class B is 128 to 191, class C is 192 to 223, class D is 224 to 239, and class C is 240 to 255. And here it is, class E is a reserved IP addresses. These class C ranges in generally we cannot use in any network. Okay, we are not using any network, both public and private domains. We are not using class C address. We can't assign to any device, and also we are not using this right now because it's a reserved, maybe in future purpose or any special purpose. But right now we are not using it. And class D is a multicast address. Class D ranges also we can't able to assign to any device. Class D ranges also we can't assign to any device. The class D, the multicast addresses. Please fill in. Just a second, guys. Wait. Okay. Okay. So here it is. These multicast addresses used by different services like different or routing protocols like RIP version 2, not version 1, RIP version 2, AZRP, OSPF. So there are broadcasting, there are multicasting to other routers with the same configurations like RIP version 2 to RIP version 2 in another router's configuration. And different other protocols like remote installations related multiple device configurations. Okay. So for example, there is a service called WDS, Windows Deployment Services. It's like a server in Windows Server. If you configure that one, so we no need to install any OS. What we require, we need a OS CD or OS pen drive to install OS, right? But this time not required. Through network, you can install the OS. Okay, through network you can boot it. You can through network you can install the operating system and the devices. For that one, two services in background it will run. One is DHCP service, another one is this boot P kind of services, boot P. So it is used both unicast messaging, unicast IP address through DHCP as well as boot P. So multicast means there's a 10 systems are installing with operating system. Means all 10 servers are connected, all 10 machines are connected to one single server. So one single server is installing to 10 machines. Okay. It means all are for one single configuration only. So it will all communicate with a single IP type. Okay. Simply say multicasting means your WhatsApp group. You put a message in the group means that is for who are in the group, all will able to see the message, right? So like a multicast. Okay. So these multicast addresses also we can't assign to our devices. And what about this first three? Class A, Class B, Class C. This Class A, Class B, Class C are from this 0 to 223. You can see this Class A, Class B, Class C are unicast IP address. Unicast means one-to-one communication. One-to-one communication means I'm sending a mail to someone, right? At the rate gmail.com. I'm sending one to one. I'm a from me to other person. Only one to one. It is it's like a what we can say unicast communication. From my PC to other PC. From my PC to google.com. It's like a unicast. From one to one communication is unicast. Okay. So group communication is multicast. Okay. One to all is a broadcast. Okay. So Class A, Class B, Class C are unicast IP addresses. So these unicast IP addresses we can assign to the devices. Again, in that one also, fewer the IP address, we can't assign to any device. That is 0.0.0 is mainly specifically it is a reserved IP address used by certain services or protocols like a DHCP services for client requesting for an IP address because you want to get an IP address from DHCP. So you're a client. So then you are a client means you don't have an IP address. So that's why you are want to get an IP address from DHCP. So you don't have an IP address. So how you will communicate? So it automatically they use this as a source address is 0.0.0. In a routing it is default routing mainly in a uh, edge type of devices. Okay, means corner type of devices. So they do not have any pass on kind of, so that they use default routing. Just concept is default. And in some other places, like the network yellow all IP addresses. Okay, deny all IP addresses. To represent also, you can use 0.0.0. It represents yellow all for yellow all yellow deny. It means all IP addresses. Okay, that is we use it for a different purposes. That's why it is reserved IP. Anyway, that 0 series we are not able to configure to any device itself. 127.0.0.1. This is also we can't configure to any device. Every device means all our laptops, desktops. Okay. By default, this IP address is inside of your system. Only for self means my laptop to my laptop communication only. Okay. My laptop to my laptop service. It's called a loopback. Okay. Or local host. Okay. So every system, my computer having one computer name, your computer having one computer name, right? But all we are having a common name is localhost. Means it's my system. When I said my name is Latif, right? Latif is my name, right? When you want to call me, you will call me Latif, right? But if I want to tell myself means what I will tell. I don't tell myself like a Latif, right? I'm saying myself. It's like that self kind of IP address. Okay. So 127.0.0.1 is a reserved IP for loopback or localhost. Loopback purpose is self-testing purpose. Localhost means self-host accessing. So within your host, within your system, you want to access your services, your web-related services or some application-related connectivity through web or maybe network connectivity. We use this IP address. Anyway, 127 series we can't assign to any device. Of course, one more is there. Okay, one more is there that is called IP address that also we'll see later. So this is the reason. So you can assign IP address from 1 to 223. In between 1 to 223, you can assign IP addresses. Of course, 127 also you can't able to assign. 1 to 123 except 127. Okay. Another range is also there, that is separate range. We'll see. So this is how to identify IP address. That is also we discuss. Always check the first octet and go through this range. So compare with the range, then you will know what is the which class of IP address. That is already we discussed yesterday. Guys, understand? Anything, any point you got refreshed, or maybe something you got understand, or maybe have getting any doubts? Any questions? Okay. No one is saying anything. So what is this is about a network and host portions. Already we told IP address is a logical address. IP address is a logical address. So for example, just think like this. You have a roll numbers. Your batch is batch 11. Think like this, your batch 11. Then I put some roll numbers like this. Okay. Roll number is 01, 11, 02, 11, 03, okay, 11, 04, 11, 05. Like this, I put a roll number. Okay. So what is this 11 indication? What is the 11 indication? Okay. 11 indicates what batch you are belongs to. what batch here belongs to. Okay, here belongs to batch 11. So that is identification. Which batch? So all are belongs to same batch. So it's all belongs to this one. For example, I want to schedule an exam. So schedule for batch 11. Send message to batch 11. So how to identify this? Right, it is their number. And what is the difference in it? So from each one, this is each person's identification number, right? So each person identification number. So this is roll number 1, roll number 2, roll number 3, roll number 4, roll number 5. Of course, I have another batches, like for example, take 10th batch, 01, 02, 03, 04, 05, 06, 1007. So it is 10th batch. So this is separate batch and this is separate batch. Even though the numbers are same, 1, 2, 3 is there, but there are separate batch. How it is getting separated? Because of this number. Okay. So this is separate batch, this is separation. Okay. Understand guys how it is separating?
Yes, sir.
Okay, good. Even your college IDs, college IDs. So for example, 402 is for me, it is my roll number. Okay. 02 means my roll number. There is a 01, another candidate is there. For 03, another candidate is there. But the 4 represents ECE branch. 4 represents ECE branch in my college. Okay. Then college code. Then college code. Then year code. Which year? Okay. Okay. Which joining year? What's joining year? College code and branch code. It is like this. So why they are separating? Even you take a pin numbers 500072. It means 5 represents the area. Okay, 5 represents which area and 0 represents Hyderabad. Okay, 72 town. 5300115 for example. It is 5353. So 53 again it is 5 so area, but 3 means Visakhapatnam and this is town. Okay, different ways you can able to tell. Even take a first floor, second floor, first floor 101, 102, 103, second floor 201, 203, 204. Okay. So what is that meaning is? So first floor, first floor, first floor. Door number 1, door number 2, door number 3. So individual identity. It is same for the IP addresses also. Okay. IP addresses also. Two parts. One is network portion, another one is host portion of IP address. Network portion and host portion of IP address. So devices in the same network, devices are in same logical network. Okay. Of course, they must be in same physical network. Okay. And devices are same network. So they can communicate each other. So they are in the same logical network means their network portion is always same. The host portion is different. The host portion is like their individual identity, like a 01, 02, 03, 04 is an individual identity. That's it is what is an IP address? Uniquely identified device in the network. In the network. Okay, in the logical network actually it is. Okay. So this is host address, for example. Understand first. Network address. What is network address? For example, network address is 1. Network address is 1. Network address is 1. Network address is 1. It means for all these devices, the network address is same, so they will communicate each other. and host address compulsory different. For example, you have another host. Here also all are connected physically, and this is 05 1.6, right, like this. Network is same. So all these devices are communicate each other. Now this network is changed. Network is different. It means this device won't communicate to all these devices. It's separate network. Logically, it is separate. Okay. Now, how these things are works? By default, if you are using IPv4 address, the first portion of the IP address is network and remaining become host portions. Okay. For example, you have a devices. You are connected with certain devices. Okay. And configured a IP address from class A range. From class A range. What is the class A range? 0 to
126.
127. Total range is 127. And we can configure from 1 to
126.
126. This is, you can assign. Okay. So I'm assigning IP address to these devices from this any of the IP address. For example, you take 1, starting 1. So this is 1 dot 0 dot 0 dot 1 I assign to this device. 1 dot 0 dot 0 dot 2. So what happened? So in a class A, the very first portion is network portion, remaining all host portions. So the condition is if devices want to communicate in the network, so their network portion must be same. Host portion can be different. Okay. So they want to communicate each other means their network portion must be same. That's a compulsory rule. Devices are in same network can communicate each other means their network portion is same. One more rule is that is devices are in same network means their network ID also must be same. We'll see the network ID part, but we'll see first is network portion part. So what is the network portion is here? First portion is network portion. So class A, the first portion is network, remaining are host. Host means individual identities. Okay, like 01, 02, 03, like that. Okay, so network portion must be same. So I put a 1.2.3. I put a 1.0.2.4. 1 dot 1 dot 2 dot 5 dot 100. But see, the first portion is network portion. So all these devices can communicate each other. No problem. But I have written here 1, then it is 2, but it is different. Guys, you can difference means in the host portion, either one host portion or multiple hosts can be different. No problem. Okay, can be different. So it is some are same, some are different from others, but no problem because okay. So when you are joining the college, first day it is everybody roll number is straight 1, 2, 2, 3, 4, 5. Second year, some are drop out. So some only few numbers are there, right? 1, 2, again 5, again 7, and 8, and 9, and 12, 13. Okay. So after dropout, but all are in same class only. Okay. So no need of host not required to follow compulsory sequence. It can be anyone, okay, but not same to same. Not same to same means in another device I configure like this 1.0.24. See, network is same, good. Host also same. As it is, host is same. Total all portions are same to same between the two devices. Then it is called a conflict. Then it is called a conflict means compulsory host portion is must be different, but not required to be all host portions should be different. Any one of the host portion is different is enough. And never configure same to same IP address to two or more devices. Okay. Because it's a uniquely identification device in the network. That's what we are saying. It's IP address means. So compulsory unique address is there. Okay. Same network and different host portions. Either it is one host portion or maybe multiple host portions can be different. So last 2 points. So I have taken first system, second system, third system, fourth one, fifth one, and sixth one. And in the sixth one, I configure 2.0.0.4. So what happened here? Take the first portion, 2. For all the system, first portion is 1. So it's a different network. So we can't communicate with a different network directly. The same segment networks, we can't able to communicate directly. So we need a router in between. We need a router between this network to this network to communicate from this network to this network. We need a router. Okay? We need a router between them to make a communication. Or you can change their IP address. For example, by mistake, you have configured like this, then you have to realize and change the IP address. Okay? You tested it, this system is not communicating to any of these 125 systems. Then what happened? Then you go to the sixth system, you check the IP address, it is showing 2.0.0.4. Then you realize actual my network ID is 1.0.0.0, right? That is my network, and this is different network. So you will going to change the IP address. Okay. So sometimes by manual configurations, generally we do some mistakes, conflicts can be possible. So in that time, you have to change the IP address to another different IP. Understand, guys, this network and host portions of class A. Understand? Network, how to check the network portion. If same, then it will communicate each other.
Yes, sir.
So for class B, what is the class B range? What is class B range? Yeah, 127 is last now. What is the starting one? 128. Then 128 to we have a nodes. You can check in the nodes also. Open the nodes. See. Now tell me what is the range? 128 to
191.
very good. 191. Okay. And so class B IP addresses follow this rule. First two portions are network portions. Remaining two portions are host portions. This is network portion, network, host, host. It means, for example, same kind of stuff. So class B means the first octet must be in this range only. So I've taken one IP address 130.0.2.4. Okay, or maybe I will take 10. So 130.10.2.4. Anything you can take it now, just for our understanding examples. This is I configured for PC1, one PC. For second PC, so 130.10.2.1. No problem, because one of the host is must be different. Any one of the host or all the host portions can be different. One or more host portions can be different. There is only one difference is there. Good. And network portion must be same. Both portions are same. So these two devices will communicate each other. Next. For another system, I configured another IP. We have to check it. Network portion. First octet 130, 130, 130. Second one 10, 10, 10. So this also same network. Logically, these are all three are in the same network. What about a host? First is different. Already I told either one or multiple host portions can be different. So all these three systems can communicate each other. Fourth one. Another system I configured by mistakenly instead of 10 I put 11. I put 11 instead of 10. Now this is, so this network portion is same, but this network portion is different. So this fourth system cannot communicate it to 1, 2, 3 systems. And I taken another system, fifth system. Here I put a, instead of 130, I put a 131. Okay. Instead of 130, I put a 131. So you check the first octet and you see these octets for 1, 2, 3. And this is a different octet. It means different network. So it is a different network means it cannot able to communicate. So you have totally 5 systems. 3 systems are communicating and 2 systems we are not able to communicate with them. So you find that issue and you check the remaining 2 systems. Of course, you check the 1, 2, 3, fourth one, fifth one, all IP addresses you have checked. Then our first 3 IP addresses, first 3 machines, their network portion is same, 130.10 only as per your plan. But fourth and fifth are having a different network portions. So what you have to do in generally, you have to again change the IP address from 10 to 11, bring in a fourth machine, 130.11 is there, instead of 11, put a 10. Remaining host is okay because host is not having any conflict with others. Host portions are not same anyway with the others, right? It is different, either one portion or multiple portions, it is different from others. Okay, so what you have to do? You have to check that 1 to 11 to 10. And you go to the fifth system, there is a 131, it is configured. Actually, it is should be 130 only. Then what you have to do? You have to change it to 130, then problem is solved, then all 5 systems will communicate each other. Point is, their network portion must be same, then only they can able to communicate each other.
So now what is the difference between class A and class B? Only the range differs or
Right. So yeah, not only a range, network and host portions also different right now. Okay, and one more difference is there. So one is the different ranges, and because of ranges, we can understand which class for purpose only. Okay, and again, if you go to the class A, first portion is network portion and remaining are host portions. Class B, first two are network portions, remaining are host portions. And what is that use and what is that differences? I will tell after class C. Okay, then we'll see class A, class B, class C. What is this range differences? Range wise differences. We'll see. Okay. So first I will tell the class C, then I will tell about the range difference, because one more is there now, that is called our class C. The class C range is 192 to 220. Class C. Tell me what is class C range.
223.
Very good. This is the range. Class C range. Okay. And so any IP address between this, their first octet is between 192 to 223, it is belongs to class C. So if it is belongs to class C means their IP address, first three portions are network portion and remaining is host portion. So class A, only first portion is network portion. Class B, first two are network portions. Class C, first three are network portions. Okay. Again, so I will take one example from here. So I can take 192, most commonly used IP address, private IP I am using here. So this is first three portions. See, this must be constant throughout the network. For first device, you configure this. Second device, 192.168.1.15. See, so both the systems are having same network portion, means both will communicate each other. 192.168, 1.25. First three portions are same between all three systems. All three systems will communicate each other. Now we'll do some mistakes. I put a 193.168, 1.26. Okay. So 193 means it is first octet itself different from existing 123. Compared to 123, the first octet itself different. It means different network, it cannot communicate. Take another example. 192, 169, 1.27. 192, 168, 2.28. So it is. So here in this second octet, it is 169. It is different from other devices second octet number. Okay. In the third one, it is in this one, in sixth system, the third octet is 2. So actually third octet must be 1 only. So you have to check all three octets. All three octets must be same in the class C. Class C type of network, all these three are must be same. Then only they will communicate each other. Okay. So again, same solution. You got 6 systems configured and 3 systems are communicating each other, and remaining 3 systems we are not able to communicate to them or from there to us. So you check all systems IP addresses. 1 second, guys. Okay. Okay, all systems are configured. Okay, and you checked each system IP address. You found 3 systems IP address is same network as your configured. The network portion is same. For remaining system, the network portion is different, either first portion or second or third one. So you see that one, you change it to actually what network portion should be changed it. So then you can able to communicate each other. Okay. Guys, understand network and host portions ranges. So you can assign from 1 to 126, okay, or 0 to 127 is full range. So we are assigning pattern. I'm typing only 128 to 191, 192 to 223. Again, in a class A, first portion is host portion, remaining are host portions. First is network portion, remaining are host portion. Class B, first two are network portion, remaining is host portion. In class C, first three are network portions, remaining is host portion. Okay, this is what we learn, right? So I'm coming from here, class C, okay, from class C. How many host portions are there?
Only one.
Only one. Means one octet. This entire octet we are considering as a one host portion right now. Okay, by default. So one host portion means entire one octet. It is one octet itself, right? Octet means 8 bits. 8 bit means 2 to the power of 8, 256. It's a 256 are there. Okay. So here sample thing is there. So just I'm going to type. Just for example, you take an IP address. So this is very first network, very first one, starting one, 0. We'll start with the 0, end with the 255. Okay, we'll start with the 0. The last one is 192, 168, 1.255. So because of it's the next one after this, if you write number wise, it is 2.0. So network portion is different. Network portion is different means it is separate network. It is a separate network. So from this to this is a one single network. From here it's a complete single network. So you can start typing like this 192.168.1.1. Then it is 192.168.1.2. Okay, it's like this. It keep goes 1.3, 1.4, 1.5, and it reaches 192, 168, 1.254. Reaches up to 254, then it is 255. Okay, this is entire one single network. Okay, again in this one also we have a rules. What is that rule? So this is the very first one in the network. Very first one in the network we can't assign to any device because it is called a network ID. Because it is called as a network ID. Okay, and you can start giving assignment to from 1. Okay, next one after 0, 1, 2, 3, 4, 5, like that you can start giving IP addresses to your devices, your laptops, desktops, servers, printers, like that. You can assign an IP address to the different network connecting devices. Okay, so that's it. This is the first one. Actually, we can assign this one. So that is called a valid host ID. Valid host ID. It means you can assign to the any device. Okay, device, host ID device. Okay, valid IP address or a host ID. First one. That it is first one. Remaining are all valid from first one is the first valid IP, second one, third one, fourth one, like it will keep on goes till it reaches the bottom. The very last one means that 255 also we can't assign to any device because this represent within that network broadcast ID. Within this network from that 1.0 to 255. So within that network range, this last one, the last IP address, we call it as the very last IP address, not last IP, we could say very last IP address is called a broadcast ID. Broadcast ID. Okay. Of course, there is certain reasons also there. So yeah, why is it? What is the differences and all? We have that one, but we'll see this first to understand. So before broadcast ID, okay, I said last, okay, not very last, okay, the last valid host ID, last valid host ID, which is it here your network actually we can assign IP addresses from this range only. From this range from 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 250, 251, 252, 253, 254. That is the last one. Then you got a 255, you can't assign it. Then if you go to the 2.0, it is different network. Okay. So the very first one we call it as a starting one is see, network ID. The very last one is broadcast ID. Okay. Through different
Sir,
simulation. Yeah, tell me.
what about 168? Like, is it a standard or it changes?
160. No, no, it won't change. Uh, this
Sir,
is
another
like one
network.
range. One range. Yeah, this is whenever it is become two, again it keep goes. For example, yeah, good question. So this is I have choose one range of network in class C like this. Because it is one private IP range I have taken out of one private IP range. This is the network I taken. Okay, so this is go to 1 to 255. Then it is become 2.0. Again 2.1, 2.2, keep goes 2.255 and 3.0. Okay, so different networks, different networks. Once this one and it is 2 here, then 3 here, then 255. Last one is 255.254 and 255, 255. And this is 168, 168. Then it is become 169.0.0. Okay. Then on it will change. Okay. So yeah, right. Compulsory, all three host portions, all the network portion must be same. All three must be same in the entire network. Okay. That means it is all belongs to same network. The network means all network portions must be same. No changes throughout the network. Got it? Got the point? So it should not be changed. It should not be 169. But if it is 169, again different network. Okay. So if you take this 0 in network ID, because this first three are network parts and it won't be changes. It's a network ID, network part. This is a host part 0. In this host part 0, the 0 represents all zeros. All zeros. All zeros. The host part is all zeros. Right? The host part is all zeros. Meaning is For example, there is I took attendance, serial numbers, 1, 2, 3, 4. Your serial number is 0 means what is that meaning? So there is no meaning, right? So no one is having the serial number 0. Okay, roll number 0 candidate won't be there now. Okay. We have one Telugu movie, it is dubbed into Hindi. They put a Hindi name is hero number 0. Okay, hero number 0. It's not like that, right? So there is no host with a 0 identification. So that's why it is called a network ID. And the last one, again, the last one, it's a broadcast ID. See, the broadcast, see their host identification only. Remaining is same. All network person is same. But check the host part. The host part, all are 255. 255. 255 means all are ones. So this is also not acceptable. Means there is no specific variable host IDs. Okay. 254 is 4 ones, 3 ones, 0. Means 7 ones, 0. But this is no zeros in the host portion. Means either no ones in the host portions or no zeros in the host portion. Both are not valid. Both are we can't assign to any device. Okay. Understand? In a host portion must be ones and zeros. Only zeros not valid. Only ones not valid. So that's the point of here network and broadcast ID. Okay. So all remaining is valid IP. Okay. So I'm taking a lot of long time on this one. Okay. So it will make more confusion to you. So this is totally 256 IP addresses. From 0 to 255. Total it is 256 IP addresses. Out of that one, 2 IP addresses we can't able to assign to the devices. So how many IP addresses we can able to assign? Minus 2. It means 254 devices we can assign the IP addresses. So in a class C, one single host portion means 8 bits. 2 to the power of 8 is 256. In total 256 IP addresses, 2 IP addresses, the very first one and very last one. The very first one is network ID, which contains entire host portion is 0. Very last one is a broadcast ID, which means entire host portion is all are ones. So these 2 IDs we can't assign to any device. So all remaining we can assign to any device. So that is what total is 254 devices. Means you are using class C means you can assign one network, one logical network. In the one logical network, you can connect 254 devices maximum. Okay. So coming to the class B. In a class B, how many network host portions? In class B, how many host portions?
2.
2 host portions. 2 means 2 8s. 2 8s means 16. So 2 to the power of 16 minus 2. Now only I am taking minus 2. Why? Because of any IP address, any either class C or class B or class C, anything. The very first one is network and very last one is broadcast. So these two are we should minus. So then only we can get number of hosts we can connect it. Number of hosts we can connect it. Okay. So it is around 65,534 hosts we can able to connect it. 65,000. Means what is the difference between class C and class B? Class C only 254 devices we can connect in a single logical network. In a class B, in a single logical network, you can connect up to 65,534 devices. You can Okay, I can calculate it. So don't type directly. Take a calculator and start doing that one. So 2 to the power of, sorry, scientific. Yeah, this is good. So 2 to the power of 16 and minus 2. So how much it is? 65,534 devices you can connect it. And coming to the class A, how many host portions are there? How many host portions? 3 host portions. So 8 plus 8 plus 8, totally 24. Minus 2, same concept. 2, we cannot use it. One is network and another one is broadcast ID. Okay, it is around 16 million 777. Okay, 214. After minus 2, it's a 214. So this is a very big one. It is around 1 crore 67 lakhs 77,214 devices we can connect in a single logical network. Single logical network. So take it. So 2 to the power of 24 minus 2. So this is 16,777,214. 16,777,214. It means 1 crore 67,070, sorry, 1 crore 67 lakhs 77,214 devices we can connect in one single logical network. So last we have taken one example, right? What is that example? 1 series, right? 1.0.0.1. So 1.0.0.1, 1.0.0.2, 1.0.0.3. It keep goes like that. You take like this, 1 dot, 0 dot, think like this, you're taken a 1, class A, 0 dot, 1, sorry, 0 is a network ID. Very first one, network ID. So all host portions are zeros only here. It is a our network ID. Okay. Next one is host ID. Okay. This is the first one. From here you can assign it. 2, 3, 254, 255, 0, 1, 1, 1.1, 1.2, 1.255, 2.0, 2.1. It keep goes till the 255 and 3.0. All are host portions only. All are host only. Okay. See, reach 255.255, 1.0.255, 255. Then it is 1.1.0.0. Then 1.1.0.1. It continues like this. So what is, where is the ends? 1.255.255.254. This is the last valid. 1.255, 255, 255. This is the broadcast ID. So this is the last IP, very last IP, that is broadcast ID. Valid 1.255, 255.254 is a valid IP, means from up to here you can assign to the devices. Okay. Start with from here you can assign, from here to here we can assign to the devices. This is we can't assign to devices. The last one we can't able to assign to the devices. After this one it is 2.0.0. It's 2.0.0. So automatically network is changes, means it's a different network. So from this 1.0.0.1 to 1.255.255.254. The total number of IP address, if you write on the paper, okay, so that's total size is 1,67,77,214 IP addresses. Okay, so guys, it's finally it is. So what's the difference? So you see the ranges are defined for identification of IP address, class A or class B class, first of all. Second, this network and host portions to create a logical network means we can create as the same network. Logically same network means they will communicate each other. Logically not same network means they won't communicate each other in the same physical network. General indirect same segment networks. Okay. Now logically same network means their network portion must be same. Okay. If you are assigned IP address from class A, so you have to check their first octet and it is class A and the first octet must be same for all devices IP addresses. Then only all these devices are belongs to same network. Okay. And host, of course, any one host portion can be different. Okay. The entire host portion should not be 0. If it is 0, then it is network ID. Entire host portion is entirely all are ones, means it is all are 255 kind of stuff, then it is called a broadcast ID.
So what about the limit of each octet? I can't understand that.
Which one?
For example, for class A, you have told 1.0.255.255, right?
Yeah, right.
So for host, what is the limit for each octet in for host and network in class A?
I type here which. Tell me one class A IP address in anything between 1 to 126.
1.125.254.255.
Okay.
For each octet, what is the limit in
So
class
each
A?
octet is 0 to 255. Okay, I got it that one. So each octet is 0 to 255. Somewhere we discussed that one. Okay, it is. Each octet size is 0 to 2. It's maximum 255. Okay, maximum limit is 2 because it is 8 bits now. So 8 bit in first octet, 8 bit in second octet. Okay, 8 bit in third octet and 8 bit in fourth octet. 8 bits means zeros and ones. Like if you're writing same IP in the binary format, if you write this same IP address in the binary format, 00000, 1. This is 1. Always 8-bit pattern only. Okay.
Mhm.
So 250, 250 to 125 in binary. It's not start with the 0, 64. 60, you minus 60, it means you got 61. I think it is 61. I mean 64, 31, 32, 61, 32. Again, it is 20, 29, 29, 1, 16, 16, 13, 8, 5, 0, 1. I think this is the binary conversion. Otherwise, you can get it here. Don't worry how to do it. You simply go to programmer calculator, right? So put 125. So then you will get it, your binary. Same. 255, that is quite easy. 255. Okay. This is the last one. See, 255 in binary, all are ones only. So this is the binary conversion of this same IP. Okay. You can use any conversion, decimal to binary, binary to decimal, any conversion method you can use it. I use different method, okay, or you can use calculators also, no problem, right? Okay. See this very starting of octet is all are zeros. Very starting octet is all are zeros. I'm writing in a binary format. Like this it will come. Okay. This is 254. This is 0, 1, 2, 3, 4, 5. This is 254, 255. After this one, nothing is there. Like once it become everything is 0 and carry to 1 to the previous one if it is available. Okay. That's why each octet size is maximum size is this one. Starting is 0. The last one is 1 for each octet. So for example, for this one, the next IP want to write 1.125.254.0. So all 255s are means all are ones become 0. Then one carry forward, that is 255. Just to understand, after 99 you got 100. Okay. 199. The next one is 200. 999 will get 1000. Okay. Same concept only. It's all numbering system only. And after this 1.127.255 1 1.255 so 125.255 2. It keep goes 1.125.255 254 means 3 4 5 up to 255 we got it 1.125 255 255. Now just think like this. This 255 will becomes 0. So 125 and 255 and this 255 completed. Next it becomes 0. 1 is carry forward. Means like 1 is going to like after 99 it is 100. After 199 it is 200. Always 99 completed, 1 will be added. 999 comes and 10 like that it will happens, right? Again, it is also become 0. 1 is added to 255, it's become 0. Again, it will forward that one to here, which is see? Now 126.0.0.1 continues. 1.126.0.1 1.126.0.2. It continues till 1.126.255.255. Then it become 1.127.0.0. Okay. But till it become 1.255.255.255, it is in the, all are in the same network only. Why? Because of the network portion is 1. It's class A network portion is 1. It means all are belongs to same network. Understand now that is octet range and when it is changing to 0 and how it is updating next to the 1 extra.
Sir, I have a doubt.
Yeah, tell me.
So class A limit is 1 to 126. What is that?
Yeah, this is one. Yeah, 1 to 126.
Yeah.
Actual class A, as per class, it is 0 to 127. Okay. So as we can't assign this 0 series, it means 0 dot anything we can't assign to any device. So that's the problem. That's why I'm writing as we have to start writing from 1. Actual range is 0 to 127. Actually, I've written that one only
Is
earlier.
it a network range or host range?
Class range. Class range means you see the IP address, you see any IP address. So you have seen this some IP address. So you see the IP address, you see their first octet, and this first octet compared with this class range table, then you will understand which class it is. Based on what class it is, there is a network and host portion is there. Okay. So based on that, these devices will communicate in the same network or not. You can able to understand. Yeah, I will, if
So the
possible, I will try
range
to.
is
Yeah, tell me, tell
so
me.
the range is for net first octet, right? Zero
Based
to
on
one
first
to
octet, always first octet. This first.
okay, it is for first octet. Since the host part has 255 limit.
Yes. So,
Okay.
like I'm checking. Okay, I will show my IP address. Go to command prompt and IP config is enough. So this is my adapter, Wi-Fi adapter, and this is my IP address. Tell me which class of IP address it is.
Class B.
Class B IP address. How can we know? See the IP address, see their first octet, and check with our table. So it is between this 128 to 191. So it is class B IP address. So this is another adapter, which is my VMware virtual adapter. This is an IP address, and this is the first octet. Which class of it is?
Class C.
Class C IP address, because its range is between 192 to 223. Always check the first octet. See, 169 class B, 169 class B, 192 class A. Okay, like this. I'm pinging to google.com. So when I'm pinging, so what happened? I will get a google.com IP address also. Okay. 142. Which class it is? It's between 128 to 191. 142, right? It's a class B IP address. It's 142, class B IP address. Okay. Based on the class of IP address, there is a network and host portion. Based on the network and host portions, number of devices we can connect in the same network we can know. And another point we can say, for example, you are working in an organization as a network engineer or network solution architect, or maybe in future, maybe you have to suggest what IP address should be used, which class IP address should be used. See, join an organization means in that network. So people want to connect a 50 devices as a single logical network, they want to connect it. 50 devices. Okay. Which class of IP address you will suggest? Just I need 50 IP addresses. 50 valid host IP addresses required. Only 50 systems. So without lesser wastage. Okay. Wastage can be there, but more number of IP addresses are not required. I didn't need as per my nearest one. So which class of IP address you will suggest? Hmm? For class C, how many IP address you are getting from class C? No one is speaking. Hmm? From class C network, how many IP addresses we can connect? How many devices we can connect? Means how many IP addresses we are getting from class C, valid one. Hmm.
254.
254.
Very good, very good. 254 IP addresses. It means in one single class C, 254 devices you can connect it. So in my network, I have only 50 computers. So which class is better? The class C means 254. Okay, wastage is 200 only. 200 I can't able to use it. Even if there is a IP address. But I have 50 devices only. So I will take from class C only. Because class B is very, very bigger one. 65,000 IP addresses. So why should we waste? You take from the class C only. Okay. For example, in my network already 50 devices are there. So I'm using class C. Now 50 more devices are added. Means totally now 100 devices. Which class is better for 100 devices?
Class C.
Class C only because 250 were.
Yeah.
Very good. Now one more 100 is added. Means totally 200 devices are there. Which class?
Uh,
Still
Class
same
C.
class, same class, same
Class C.
IP, same network only. No problem. Now what happened? 200 devices are added. Now it is 400 devices. What to do?
Class B.
Class B. Because class C in single network 254 only. After 254 again it's become another network. So we want to connect everything in one single logical network means. So 254 means class C's network is not enough. So you have to go for a class B. And class B support up to 65,000, more than 65,000 devices we can connect in the same network. Okay. So now your devices are become 1,000 class B, 5,000 class B, 50,000 class B is better, 60,000 class B is better, 70,000. 70,000 devices are there. Class B is not enough. Okay, Class A is, and because Class A is 16 million. 16 million. Okay, it means that many, like almost like more than 1.5 crore, 1.6 crores of devices we can connect. Okay, almost all more than 1.6 crores means 16,070,77214 devices we can connect, or 1 crore 67 lakhs 77,214 devices we can. It means now it is 70,000, 80,000, 1 lakh, 2 lakh, 3 lakh, 5 lakh, 10 lakh. So how many devices we can connect it. Okay, this is the one of the reason we are dividing our IP address total range into the different classes, class A, class B classes. And another is we are dividing into network and host portions in different ways. You can make a class A like one network portion, remaining are host portion. Class B, class C also same type only. You can make this is a network and that is a host portion like that. But why it's a different in the classes with a different network and and host portions? Like class is only one network portion, class B first two are network portions, class C first three are network portions. Because to divide the size of the network, you can choose different sizes of the network, and more networks, lesser networks you are getting. Okay. Even you take a ranges. Okay. Even you can take a ranges. The class A, only one network portion, remaining are host. Okay. See, only one network. It means the range of this is from 0 to 255. But of course, as per class A, class B, class C, okay, the range network, this part, as it's a class A, that too it is class A. So it is ranging is from 0 we are not using. So, and 126 is last one, because 127 also we are not using. It means how many networks in class A, how many networks in class A is 126 networks. Okay, 126 networks only we are getting. Of course, 128 networks we are getting, but we are using 1 to 126 networks because 1 to 126. Networks we can use like 1.0.0, 2.0.0, 3.0.0, 4.0, 5. Like up to 126 we can get it. Okay, 126 networks. But so many hosts in a single network, more number of hosts. In a class B, it is 2 portions are network portions. Okay, 2 portions are network portion, ranging is 128 to 191. Of course, already I told there is a one series is there, 169.254 series is there. So this is we cannot using it right now. But other than that one means entire 128 to 191, you can use it. So this range is up to 128 to 191 for the first octet only. But second octet is 0 to 255. Okay. It means you take 128 here, 0 here, host and host. Means this is like a one network, starting network. Okay. And it will still goes to 128, 1, another network, 128.2, another network. But 128 is not changing up to 255. Okay. This is also another network. Okay. So this is our, now it is again 129. Still it is class B only. Again it start. It means each one 128 to 191, each one getting 256 combinations. 256 combinations. Okay. So that much of big one. Okay. So 129 to 191. So what's the difference? 128 to 191. This is 198. $191. Around 63 differences. 63. Plus this is 63. Okay. 63 into 1256. Those many networks you are getting. Okay. In class A, number of networks are 126 only. But in a class B, 63 into 256 number of networks we are getting. In a class C is so many. In a class C, it is very different. Okay. So many 256 into 256 into something around 31. Okay. 31. That's the difference. For example, this is 120, 192. Okay. This is 223 in binary. So this is the only difference, right? This part only difference. It means it is around 31 or 32. So if you take a range wise, 32 is the total range. So 32 into 256 into 256. Okay, so that much of number of networks also we are getting, but number of hosts are less. I am taking lot of things. Okay, simple to get it, guys. Okay, for identification of IP address, which class of it is, the ranges are helpful. And each class of IP address, by default, there is a network and host portions. And two or more devices are communicating each other means their network portion must be same. Then only they will communicate each other in same segment of network. Okay. So two devices are in the same network means their network portion is same or their network ID is same. Okay. I've given some examples. So then read the examples and do it. And also written entire host portion may not require to be same. Okay, it can be different of any one of the host portion. Okay, there's subnet mask. So we'll discuss subnet mask once. Take a small break because you are also learning for longer time. Take break. For 20. So we'll try to finish this remaining part of this IP address, subnet mask, default gateways, NAT and PAT afterwards. Okay. Take a break. Back at 12:20.